is e to the x minus e to the a over e to the x. Do you agree with that? We still good? Which one is this number? Yeah. Whoa. Shit. Sorry, bud. That's your book. I'll get you. Damn it. Wow. I destroyed it. Make sure I didn't bend any pages here.
He's like, there goes my deposit.
Okay. I think it's okay.
We can multiply that through.
You can multiply that through. You're going to have, if you do it, you're going to have a triple. Let me get rid of this.
But it's still not going to make pretty.
Yeah, it's still not, right? Let's just check to see what we have right now again. And let's pay a little more attention to detail now when we look at what sort of limit this is. As we let x approach a, this is becoming negative sine of a, which we are just going to say is a number. And it's a negative number, isn't it?
Yeah.
Possibly, because we don't know what a is. But and then here, this is headed towards negative infinity. Right? Do you all agree with that? And then plus cosine of a, which is just a number, over 0. But that's a little positive number down there. And do you know what cosine of a is? Do you know if it's positive or negative? You don't know. You don't know what a is, do you? Right? So I know, the most I know about this is that this could be positive or negative infinity. I don't know. And then over here, what do we have? E to the a minus e to the a, 0 over e to the a, right? Which is 0. You agree with that? Hmm? What, this right here?
Positive, yeah, because it'd still be on the right side of a, so it would be like e and a plus minus e to the a over e to the a plus.
It's still going to 0 though, because they're headed towards each other. I mean, this is headed towards a, so these are getting really close to each other. The difference of those should still be 0. It should be. What was your?
I look at the edge of the book, see where it's kind of going.
It's an even number.
It's an even number.
There's no answer. Okay, so this appears to be very different than any of the other problems that we've had, right? Do you all agree with that? I mean, the other ones were just smooth sailing until we got to this one.
So we have
This looks like right here a 0, right? Yes, that looks like this is going to 0. And this right here, if I look at the whole thing, looks like could possibly be some sort of infinity here.
Yeah.
Some sort of infinity, because I've got like infinity, I'm not quite sure if it's positive or negative. I've got infinity here, could be positive or negative. I don't even know for sure, but I'm thinking this looks like infinity. It looks like infinity times 0 possibly.
Is it a plus or minus?
That's what I'm saying, I don't know. This is the form I have. So I have to make a decision, like how do I want to proceed from here? The only thing that's going to help me is L'Hopital's rule, right?
Could we do that again?
We could do it again. Not here though, because now I've turned it into infinity times 0 instead of like infinity over infinity, right?
We can't change the ratio.
We say again?
We can't. Because before it was infinity over infinity, now it's infinity times 0, so now I have to go back to the original.
That's right, we would have to go back to the original. Okay, so let's erase this. And let me rewrite it. Cosine, limit x goes to a from the right. Cosine x, I'm going to rewrite the problem originally. Times natural log of x minus a over natural log of e to the x minus e to the a. That was our original problem, right? And we said that this was infinity over infinity. We took the derivative one time and it was very ugly, and tried to turn it into something, wound up being 0 times infinity. So I'm going to go through it again. I'm going to just write down our derivative the way we had it after the first L'Hopital rule. So we had negative sine x times natural log x minus a plus 1 over x minus a times cosine x all over e to the x over e to the x minus e to the a.
So if you do it again, we're going to have to quotient rule down.
Say again?
If we take another derivative, we're going to have to quotient rule.
Yeah, we will have quotient rule here if we take the derivative down here. But we have to have infinity over infinity, or 0 over 0 to do that. And I don't think we had resolved that. We had not determined whether or not we had that or not. So, do we have infinity over infinity? This is negative infinity right here. We all agree with that, right? Negative infinity. This right here is what? 1 over 0. The a we're plugging in is a little bit bigger than a, so it should be positive.
We don't know what A is, though.
Yeah, but this is a little bit bigger than it, to the right of it. So the difference should be positive. Yes. It's not an assumption I'm making. It's the fact that I'm approaching it from the right.
What if there's like a negative number?
Okay, so if I have like negative, let's say negative 3, and I approach it from this side, like with negative, what? Negative 2.99, right? So what would we have there? No. You're plugging in negative 2.99 here, and then you're subtracting from it what? Negative 3, so it'd be positive. So we'd still be positive infinity there. That's okay. The problem that we're really having is knowing what this is, right? Yes, but when you plug in a, we don't know what the value. We don't know what a is, do we? We don't know what a is.
We let A be something?
We need to investigate what a could be. Now, I need to know about right here. This is going to cosine of a. This one is going to, I'm going to write negative sine of a. Or actually, let me just put sine of a. We'll deal with the negative in a minute. All right, so let's talk about it. If I'm interested in knowing what these are, then I can look at a as being an angle, right? Inside of a trig function? Yes? Okay, so my angles can come from any of those 4 quadrants. What if we're in the first quadrant? What can you tell me about both of these? This would be what? Positive. So I'm gonna just put it over here. If I'm over here, cosine of a is positive. What would sine of a be here? Would be positive. And what would happen here? This would be positive, right? So this would be positive infinity. Sine of a would be positive, which would be negative, right? Because there's a negative in front of it. Negative and negative would be positive. This would be positive infinity on top, right? Agreed? All right, what if we are over here in the second quadrant? What's cosine of a over here? What's sine of a here? Positive. So what would happen here? See, this would be negative, right? So that's negative infinity. Sine would be positive, right? So this would be what? Negative times negative, which would be positive. So we'd have positive infinity and then plus what? Negative infinity. What's positive infinity plus negative infinity? It's indeterminate, right? So in this case, we had infinity on top, right? And then infinity on bottom. In this case, we had indeterminate on top and infinity on the bottom. And if we go through these two, what's going to happen? Same thing. We're going to have either it's going to be infinity on top or indeterminate on top. All I've done is tried to convince you that no matter what we do here, we have an indeterminate form. This is still indeterminate, regardless of what A is. Okay.
So we need to do it again.
I don't want to do it again. I don't want to take the derivative again.
Then how are you going to
Let A be some number. We'll get there.
If we let A be a number, then we could maybe get some sort of pattern of what's happening here. We could, possibly. Right? We could. But I don't think we need that in order to do the problem. Because imagine if I just replace this with 2, that would be 2, and that would be 2, and that would be 2. We'd still have the same issues. We'd still have undefined, right? So it's not going to change the fact that we have an issue. All right, I don't want to do it. I really don't want to do it. But
how are you going to get around it though?
yeah, I don't see a way around it. Well,
You can't introduce a property of logs.
Could you move the cosine over and switch out the natural log with the cosine since it's multiplied? Or put it on the other side of the natural log of x minus a?
over here?
Yes.
Yeah.
Because it's multiplied.
Mhm.
And then you could do property of logs.
Don't have property of logs. It has to be 2 different logs. I'm sorry, it's 2 different logs. It would have to be a single log with division inside. This is 2 separate logs,
Oh,
right?
okay.
Yeah, if there was a log property that I could use, I would have already pulled it out and used it because it would have probably made things easier. All right, well, let's do it. I have no choice. I'm going to take the derivative again on top and bottom. And I'm very frightened of what that derivative is going to look like. Here we go. Limit as x goes to a from the right. All right. Derivative of this. This is product rule right there. You see that?
No.
Derivative of this is negative cosine x times natural log of x minus a. That already I'm not happy about. Because I know that that's going to go to negative infinity, right? But I'm going to keep going. Plus derivative of this, 1 over x minus a. We've done that already, right? Times sine x. That finishes off the product rule there. Negative sine x, thank you. Okay, that takes care of that. Plus another product rule right here. And 1 over x minus a, we have to take derivative of that, don't we? Bless you. We have to take derivative of that. I could use quotient rule. I could also rewrite that like this. And then take the derivative. And then do the power rule with chain rule. I'm going to do that. So what would happen if I take derivative here? Negative 1, x minus a to the negative 2 times derivative what's inside? 1. So that's just going to turn into negative 1 over x minus a quantity squared. That's what that is. That's the derivative of that piece right there. Times what? Cosine x. My goodness. Now what? Plus? Negative sine x, right? Negative sine x times 1 over x minus a. Okay, am I happy about any of that? I don't think I'm happy about any of that. Right? Huh? That's the derivative of the top.
Hold on. Actually, yes, we are. Because that sine x will
I was hoping these would be opposite in sign.
Oh, yeah, they're not, okay, yeah.
I was hoping this would be a positive one,
Get rid of cosine.
and then that one would cancel.
You can. No.
Cam what? No, I can't cancel anything. Okay, I keep going. So what's the derivative of the bottom? Quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top. Derivative of the top. E to the x times the bottom. I keep on doing that. That's derivative of the top times the bottom, right? Minus what? Derivative of the bottom. What's the derivative of the bottom? Times the top. All over the bottom squared. Oh my goodness. This is so wrong in so many ways, this problem. Do you see how, I mean, this is a complete disaster. Complete disaster. I don't see anything that's making this any better.
I mean, on the denominator, would you be able to get rid of 1 dx minus
You could, but you'd have to split it up into 2 first.
What if you
Yeah.
factored on the bottom when you factored out at CDN?
This is like one of those trick problems, where it's just like, okay.
It is kind of like a trick problem. It's to teach a lesson. And the lesson is that even though I want to shake L'Hopital's hand, L'Hopital's rule doesn't always make things better, right? Every time I'm taking the derivative here, it's becoming more complicated, isn't it? Like I would not want to go and do L'Hopital again. I'd first have to convince myself I have a problem, right? And then try and do L'Hopital again.
What if we go back simple and try and do the old way?
What would the old way be?
Try and find some sort of common factor out.
Okay, so can we all agree at this point?
Yes.
This isn't getting better. L'Hopital's not helping us. Yeah?
Maybe the base factor is something else.
So maybe there's something else that we can do.
What's that whole page? Just let them use this.
Hey, don't get mad. This is what makes math really math. It's one thing to come up here and just you watch someone do the problems over and over and over. When you get home and you get stuck, this is what you have to do. You have to keep going after it. You can't just, well, I don't know, and you know, they didn't show me how to do the problem just like that, so I guess I can't do it. You know, it's not like complete copy. You have to just think through everything. So, is there anything that we're missing here? X is going to A. Can't use any log properties, right? Can't split that up.
You can't make it 2 fractions and then you'll have ln in. Oh no, because then the cosine will have its own there.
Yeah. Okay.
Yeah, what if you did
So are you ready? Let's.
Multiply by 1.
Okay. Hang tight, everyone. This is the same as this. Do you all agree? Okay. Now, when I look at this way, what is this going to? Cosine A, right? Is that a problem? That's not the problem. What's the problem? This piece, right? What is this piece over here going to? We already talked about it. That piece right there is going to negative infinity over negative infinity again. This is the part that's having the problem, isn't it?
So we're going to take the derivative of that instead?
So what we're going to do is, this cosine x was only thrown into the problem to see if we're just going to go L'Hopital at it, just go after it. Or if we're going to think through, I mean, when we did L'Hopital one time, wasn't it kind of the cosine x product rule that was causing the major issues? Right? Because I kept on, having to do that product rule, I kept on getting more terms on the top. Right? When you do product rule? Hold tight. But if I say, look, this is not the problem. All I'm really interested is what happens to that. Let's say that that goes to 2. Then my answer would be what? 2 times cosine A, right? Right? Okay. So the point of this problem is that if you go and do L'Hopital's rule and it's getting uglier and you can't get to it, you have to go back and reanalyze and figure out where's my issue. Where's the problem occurring? Where's the bad stuff occurring? And this is it right here. It has nothing to do with this, has everything to do with this. Now, did you have a question?
It's not negative infinity over infinity. I thought it was 0 over 0 there.
No, because this is 0. This goes to 0. But natural log of 0 goes to negative infinity.
Oh, right.
Yeah. Right, so what I'm going to do now is I'm going to kind of like start the whole problem over as if someone just asked me to figure out this. That's all I'm going to look at, because isn't that the only thing I'm concerned with? That's all I really care about. You are allowed to do this when you're looking at limits. I don't know if you remember this property of limits, but it said this. If you have the limit as x approaches whatever of f of x times g of x, it's equal to the limit as x approaches whatever of f of x times the limit as x approaches whatever of g of x, right? The limit you're allowed to split up. That you can do. So if I split this into, this is like the f and this is the g, right? If I split this into 2 limits, maybe just doing this one by itself will be better. It will, definitely. I mean, we're not going to have to use product rule. All right, so let's do the L'Hopital's rule on just this one.
Just out of curiosity, at what point did you realize this?
Well,
The whole time.
I'd be lying if I said I saw it right away. After the first time I took the derivative, when we first did L'Hopital the first time, and I looked at that answer, I could tell that we were going to have to split it earlier. Like we were going to have to peel that cosine off. But you have to know when that's going to happen. When we did the derivative that second time, that was like for sure stamp on the problem. This is not going anywhere, right? So let's go now, and I'm not even sure if this is going to get it. All right, let's try it. What's the derivative of the top? 1 over x minus a. That's not so bad, right? That's not so bad. 1 over x minus a. I'm sorry? I just took the derivative of that. Yeah, I know, but just keep going. What's the derivative of the bottom? E to the x over e to the x minus e to the a. Haven't we done the derivative of this twice already now? Okay, let's clean this fraction up. Let's clean this one up and see what we get. So flip this up like this. Limit x approaches a from the right of, what will be on the top? E to the x minus e to the a over, what's on the bottom there? X minus a times e to the x. I'm going to write it like this. What are you thinking now? Let x go to a, right? Do you all see where this came from? Any questions? I feel real good about this. X is going to go to a. E to the a minus e to the a is what? 0. Why do you think I'm most happy about this? What's not here anymore?
The cosine.
Well, yeah, the cosine, but I pulled that out. I'm saying, what's no longer appearing in here? The logs are gone, right? When I had the cosine in there, the logs came with me, right? Here, the logs are not going to be part of the problem anymore. And that's going to be a good thing. The top is going to 0. Do you all agree? The bottom, e to the a, right? This is going to e to the a. E to the a. And then what's this times? 0. Ah, okay. We have what? 0 over 0. Now, are we afraid to take the derivative again? No, because look at how nice this is going to start getting. What's derivative e to the x minus e to the a? What's derivative of that?
But the ratio changed, no?
What's derivative of that? E to the x. What's derivative of that? 0. See, it's going to get better. Instead of getting worse, it's going to start getting cleaner.
I thought you said we could take the derivative again if the ratio had changed.
Say it again.
I thought you had said we couldn't take the derivative again if the ratio had changed, because we're not dealing with infinity over infinity, and now we're dealing with 0 over 0.
But L'Hopital works if you have 0 over 0 or infinity over infinity. It doesn't have to stay 0 over 0, 0 over 0, 0 the whole time. It can be 0 over 0, switch to infinity over infinity, back to 0 over 0. It doesn't matter as long as it's one of those two. All right? All right, so I'm going to do L'Hopital again. Limit x goes to a of derivative of the top you said was e to the x. I think, right? That's what y'all agreed with me? What about the bottom? What are you going to have to do there? Product rule. This is a product, right? So derivative of e to the x is itself times x minus a plus, now the derivative of x minus a. 1 times e to the x. And now you should be ecstatic. Why should you be ecstatic here? They all have an e to the x. Every single one of them has an e to the x. Right? You can factor out an e to the x out of the bottom, and then you'll be able to cancel that factor completely. Limit x approaches a from the right. What would it turn into? 1 over. I pulled an e to the x out. Of this one, I pulled e to the x out. When I do that, what am I left with? X minus a plus 1. Don't forget that plus 1. It's very important. All right? So I have x minus a plus 1.
So, wait, what do you do with e to the x? Does it go on the front?
I pulled the e to the x out of here and here, right? And then I had an e to the x on top, and I canceled this and this. That's a 1, and then all I'm left with is this. Do you see that? The answer is 1.
No, it's cosine.
And then we have the cosine. Yeah, we can't forget that. So we let x go to a, and we get 1. Everyone follow that? So let me go back to the original problem. All right, the original problem was the limit as x approached, or sorry, cosine x, no. Cosine x, natural log x minus a over natural log of e to the x minus e to the a, right? That was our original problem. And that equals the limit as x approaches a from the right of cosine x times the limit as x approaches a from the right of natural log of x minus a over natural log of e to the x minus e to the a, which equals x goes to a, cosine of a, times whatever this limit is, but I just showed all my work for that limit. That's 1. The answer is cosine a.
What was that property you used again to separate the multiplication between the cosine x and the...
Right here. That's just a limit property. If you go back to the section on limits, if you go back to the section on limits, which is page 35, let me make sure it's 35. We have these things called the limit laws. And it's property number 4. Okay? You can split limits up. You can't do the same with derivatives. You can't do a derivative of a product and just split it into 2. That's the product rule, and that's what makes derivatives a little harder. That was a good problem. But now you know, right? Now you know. You start doing a limit, you start doing L'Hopital, it starts getting crazy. identify the piece that caused the problem. Identify it. Isolate it. Do L'Hopital on that part, and it's probably going to work out a lot better.
So find the crazy, get rid of the crazy.
Yeah. So what if I would have started the problem, I would have said, okay, for this, I'm going to just do this. I think it would have been less intuitive. Like you would have been less convinced that, like, why do that, you know? Now do you see why that's important to like separate it? That cosine x causes a problem when you try and apply L'Hopital's rule. It creates that product rule.
I don't think you would ever got to that answer if you didn't take that out.
I don't think it would have happened.
You can just separate it without having to put an ln ex underneath it.
ln ex where?
Cosine x. Like the cosine over ln e to the x minus a.
Because that's all one term up there. It's like if I say, you know, what's 2 times 3 over 6? I can rewrite that as 2 times 3 over 6. Right? That's a half. 2 times a half, that's 1. But that's also 6 over 6, that's 1. I mean, if it's addition, of course, we can't do that. All right, that got me going a little bit. I got the blood flowing in the brain a little bit on that one. All right. We have time for one more, I think. Have y'all noticed that we have only dealt with these two? You see why I've reserved 2 days for this? All right. 24. What's that saying? It's something like, something me once, shame on something, something me twice. What is it? How's that go?
Fool me once, shame on you. Fool me twice, shame on me.
Yeah, fool me once, shame on you. Fool me twice, shame on me. Yes?
If we ever see like x to like another variable, is it possible if we could just treat cosine, sine, tangent just as a constant? Like whenever we see that, we recognize that, we just take cosine or tangent or sine out and just do whatever is left. If it's x going towards a variable. Would you do it like that every time you see something like that?
Okay, you just separate your limits all the time.
I don't know. I mean, I wouldn't want to tell you if you see a cosine in there to always just pull it out like that. I wouldn't want to tell you that because it actually might be useful. Like, look at the ones we did before. Remember where we had like
Oh, but that was
cosine minus 1 and...
that was the x going to a number that you gave me. Like going to 0, going to 2, but now it's going to a variable. I'm just saying.
Well, it's not going to a variable. I mean, it's going to A. Well, A is still a number. It's still a number. It's just not given to you.
Yeah.
So I don't think, I'm not going to say that, yes, when you see that, always pull out. I'm not going to say that. I think that would be, for me, yeah, I mean, that could lead you into bigger problems, I think. All right, let's take a look at this one. Oh, yeah. All right, x goes to infinity. What do we have?
Infinity to the
Negative
Square root of infinity.
infinity.
Infinity. So this is headed to infinity. E to the,
negative power.
plug in infinity right here. I know you can't plug in infinity, but half of infinity is what? Still infinity? And then negative. Negative infinity? So this is really headed towards like e to the negative infinity. And what is e to the negative infinity headed towards?
Negative infinity. Well, e's a constant.
Yes, but we're saying look at the e function. And what happens when the power goes to negative infinity? It's headed towards 0. So look, this is the e to the x function, right? If I say what happens, e to the infinity means start going out this way and tell me where the function heads. Where does it head? Goes up to infinity, right? But if I say e to the negative infinity, what I mean is start heading in the negative direction on the e function and tell me where it goes. So where does that go? 0. See that? So this is headed towards 0. So I have infinity times 0. What if this had been just x over 2 instead of negative x over 2? It would have been e to the infinity, which would have been infinity. And infinity times infinity would have been infinity, and we would have been done. So I'll just change it to a positive? No.
I like that problem.
Okay, so what happens when we have this? We have not seen this situation, all right? This is the first problem that I'm showing you where you have a situation of 0 times infinity. We know it's indeterminate because one's getting big, one's getting small. You can't use L'Hopital yet. Why not? It has to be 0 over 0 or infinity over infinity. What we're going to do is we're going to create a fraction out of this. We're going to create, I like that, create a ratio out of this expression.
What would we do? Is there an easier way before we start doing it?
What's that?
Is there an easier way to do it before we start?
Nope. Nope. This is the easiest way to do it. So what do I mean? I want to create this. My goal is to try and get it to look like this. All right? So here's the standard trick. And notice I'm not doing L'Hopital's rule yet. I'm just going to rewrite this. You just tell me whether or not you believe me that this is true. Do you believe that that's the same expression? So I have a couple of votes for no and a couple of votes for yes.
If you do the math, it is the same.
It is the same. It's like me writing, if I write 1 over 1/2, everyone would agree that that's 2? Right? So if you ever have something, you can always write it as a fraction by dropping it down as 1 over that. Agreed? So what I did is I chose to take the root x and drop it into a denominator as 1 over the root of x. This is the same expression. I have not changed anything. I've just changed the way it looks. But it's the same exact problem.
But now it's 0.
But now let's take a look at what it is. If you look at the top here, this piece right here, where is that headed? That's headed to 0. And where is this headed to? 0. 1 over root x is 1 over infinity. 1 over infinity goes to 0. So we have just been clever, and we have dropped one of our factors down to the denominator and created the 0 over 0 we need. That's the standard trick. When you see 0 times infinity, you will grab one of them and drop it. Now the one that you pick depends on the problem. And it really is up to you. I could have dropped the E one, couldn't I? Let's see, maybe I should have done that. But do you all agree I have 0 over 0? So I could proceed with L'Hopital. If I did L'Hopital on this, derivative of that would be pretty clean. Derivative of this, quotient rule, or you'd have to rewrite this as x to the negative 1/2 and then take the derivative. That's what I would have to do here. I want to revisit the problem from the beginning again. This time I'd like for you to consider dropping the other one down. What would happen if I dropped the other factor down instead of the root x? What would I have? Root x over 1 over e to the negative root x. Right? That's what I would have? Can someone tell me another way I could write that? Can I just drop it down? It's a negative exponent, right? Negative exponents I can always rewrite by dropping them down. So couldn't I just write it this way? Couldn't I do that?
Can you write that as a root?
Say it again.
Can you write that as a square root? Like, put that 2 up there.
Where this?
Yeah, turn that to the square root of e to the x.
You could, yes. You could. But what I'm trying to get here is either 0 over 0 or infinity over infinity. That's what I'm trying to get. And by rewriting it this way, do I get that? Let x go to infinity now. What happens? This goes to infinity, and this goes to infinity this time. See, because we dropped it down, it's now a positive exponent. E to the infinity is infinity. We get infinity over infinity. either way, right? Either way I choose, I'm going to get what I need. 0 over 0 over, or infinity over infinity.
That one's better.
That one's better. Why?
It's a lot cleaner.
It's a lot easier to differentiate this. So can we take a vote? Y'all want to do this one? Let's do this one. So by L'Hopital's rule, x goes to infinity. Derivative of the top, 1 over 2 root x. That's derivative of the square root of x, right? What's the derivative of e to the x over 2? Itself.
Plus
Times the derivative of what's up here. What's the derivative of x over 2? And please don't tell me quotient rule. X over 2 is 1/2 x, isn't it? What's derivative of 1/2 x? 1/2, okay. I'm out of time here, but this is actually not a problem anymore. Let x go to infinity right now. What does this go to? 0. What does this go to? Infinity. What is 0 over infinity? 0. This limit is 0. All right, I'm out of time. I recommend that you start your homework for this section. Work everything up until problem number 23.
If we try to go further, would that be bad?
If you try and go ahead, read the book at least before you do it, yeah. Because we're going to have something, do you remember with differentiation we had logarithmic differentiation? Same sort of thing here. We're going to have a way of doing these where we're going to have to bring log in on both sides. So if you try and do them without it, it's going to be a mess.
you could do that with a limit.
Yes. Yeah, it's going to be kind of weird, but